Welcome back to the channel, Bridging the Gap Student to Engineer, where STEM professionals provide advice to students. This video is specifically about the discipline of chemical engineering. We're going to do a deep dive into chemical engineering today. If you haven't seen our other videos, we have a series of discipline deep dives that is building. So if you don't see what you're looking for, please leave a comment and we'll make a video for you and for others. So let's get started. Okay, so chemical engineers, just like all engineers, identify, formulate, and solve complex engineering problems by providing the principles of engineering, science, and math. No matter what engineering you go into, you will be learning how to do this. So the context in which chemical engineers do that is they research, design, and improve equipment and processes for manufacturing products. You'll see themes as we go through this: equipment and processes features heavily because chemical engineering is very focused on process. You may or may not be having a job that's specific to chemicals, although chemicals make up everything that we have, all the materials we have, so there's a lot of applicability there. I do have a friend with a degree in chemical engineering who pretty quickly went into control systems because that is an area that's heavily into processes and where chemical engineering applies. Okay, so chemical engineers also monitor production processes and troubleshoot problems. So again, processes, manufacturing, those types of things. Establish safety procedures for working with dangerous chemicals. The chemical engineers are the ones that understand more deeply the chemicals involved in a lot of the processes that we have, whether that be pharmaceuticals, oil and gas, fertilizers in agriculture, those types of things. We use chemicals in everything. And so for chemical engineers understand those chemicals and understand the safety procedures, the processes, and the manufacturing around all of them. Okay, and then they also evaluate the equipment and processes to ensure compliance with safety and environmental regulations. So we had talked about safety earlier. This is also environmental because while it is important to keep people safe, it's also important to keep the environment safe. So you also find chemical engineers involved in sustainability and those types of areas because they have a broad understanding of the chemicals and how they impact people and the environment. Okay, so the career outlook, this is from the Bureau of Labor Statistics. I will provide the link with all of the other links from this video in the description, so please take a look at those if you want more information. But the 2023 median pay for everyone with a title of chemical engineer is $112,000. That is about the middle of the road for engineering as a whole, but significantly higher than a lot of other careers outside of engineering. And then, like is typical with all engineering, the entry-level education is a bachelor's degree. To me, one of the big selling points of engineering as a whole is that you don't need a lot of extra education to get into the industry and into a really high-paying job. So that's the case for chemical engineering. Then when we look at number of jobs, job outlook, all of that, the Bureau of Labor Statistics predicts that chemical engineering will be growing much faster than average. To give you just a point on this, their criteria for faster than average is like 6%, and this is 10%. So this is significantly more. If you think about things like creating new and better batteries and a lot of things that the world is getting into now, chemistry is involved in all of that. So I could see why it would be growing much faster than average. Okay, industry organizations. I know this is a lot of words on one slide. We present you with industry organizations because, as we talk about in our other videos about finding jobs, finding scholarships, those types of things, Industry organizations are important, even when you're just getting into school, or even if you're looking at a discipline. Looking at the websites for those industry organizations is important to understanding what people in the industry are saying, what they're doing, how you might be able to get involved, either at your school or outside of your school, and if there are scholarships or mentoring opportunities that you can get through these organizations. So one thing that is very nice about the American Institute of Chemical Engineers is they have a lot of sub societies or sections for specific areas of chemical engineering. And this is really just showing you how vast the field of chemical engineering is and how widespread it is in different industries. So we've got the Center for Chemical Process Safety, we got physical properties, manufacturing, biological engineering, process engineering, energy, hydrogen, and that's just the first column here. And what this is really showing you is chemical engineering applies to quite a number of different industries. When we talk about like aerospace engineering, that is a degree to get into an industry, and you might be able to apply that to other industries if you can't get a job in the industry that you just got your degree in. Chemical engineering is very different from that. It's kind of the opposite, where you're learning about a specific thing, chemistry or chemical, but it applies to so many industries. You could get a degree in chemical engineering and go into aerospace if you wanted, but you could also go into water resources. You could go into safety. You can go into pharmaceutical. You can go into construction. There's a lot of different things you could do with a chemical engineering degree. So look at their website and see what you can find, see if there's something that sparks your interest. Okay, aside from that industry organization, there's the American Chemical Society and the Association for Energy Engineers. And then the last one I have on here is a minority engineering organization specifically for chemists and chemical engineers. It is pretty typical to have minority engineering societies that are across all disciplines. It is not super typical to have a minority society for also a discipline. So it is nice to see that within chemical engineering and chemistry. If you are someone who is a Black chemist or Black chemical engineer, or if you are interested in supporting them and bringing them in, this is a good organization to take a look at and see if you can get involved. But definitely take a look at these organizations, see what you can find, and see how they can benefit you, and you can also become part of a bigger group. So schools. There are 170 ABET accredited programs. That is a very high number. It is not the largest, but it is one of the largest because chemical engineering is one of the basic engineering. You can go to a lot of different schools. You'll see on here a lot of state schools, but you'll also see some private schools, and the wide availability of chemical engineering programs really indicates how big and how broad and how much flexibility you can have if you go into chemical engineering. And one thing to look at when you are looking at schools is some of these schools will have specialized laboratories or a focus on specific industries and those type of thing. Probably the easiest example I can give on that is if you are majoring in chemical engineering in Texas, the likelihood that you will go into oil and gas is higher than if you were going to, a school in Washington State and majoring in chemical engineering, because the industries in those two states are very different. The schools are going to have partnerships with those industries, and those industries are going to be recruiting from them. So something to think about if you do have flexibility to go anywhere in the US is that different areas of the country have different focuses as far as industry. and the likelihood you'll get into a specific industry is higher if you go to a place that's near there. Okay, so outcomes. This is what I believe is the biggest and most important piece when considering a school, but it's also important when you're considering a discipline. So for chemical engineering as a whole, I'm going to skip over to the fourth column there, percent grads, positive outcomes. We have what half the schools here are in the 90s and half in the 80s. I like to see everything in the 90s, but there's nothing in the 70s. So if we think to the aerospace engineering, there were some of these positive outcome rates in the 70s, and that's really not what you like to see. Chemical engineering, because it is so broad, gives you more options, and the percents of positive outcomes here are reflective of that. So let me just start over a little bit here. So the schools that are listed here are not necessarily the best or the ones that I recommend. They're just ones that provide a lot of data. And so I'm able to provide the data here. I believe from what I have seen, they're pretty representative of all the schools across the US, but definitely look into the schools that you're interested in, because there is a wide variety of positive outcomes. So when we say positive outcomes, that's the percent of students who either were looking for a job and got a job, or were looking for going to grad school, got into grad school, or maybe they wanted to go volunteer or do a mission or something where they had some positive thing that they were doing after graduation and they were able to do it. If you look at the converse of this, the ones who didn't have positive outcomes are the ones who 6 months after graduation are still looking for a job, still trying to get into grad school, still trying to do something. And that's not a very comfortable position to be in when you've just spent 4 years getting a degree. So look closely if you are looking for specific data for specific schools. I provide the link to all of these schools in the comments of this video, but also we have specific videos for all these schools, so take a look at those. Okay, so let's skip around again. We're doing that a little bit on this video, but the percent of total engineering, this is the number of students in the major compared to the number of students in engineering at the school. And all of these are around 10%. 10% is a pretty good number. That means like 1 in 10 of the engineering students are in chemical. That means these programs are not teeny, but they're also not huge. But if you look at the actual number of grads annually, at least in this sample, they range from 39 at Colorado State. So that's a pretty small class. If you think about the number of people in your high school classes that you're sitting with, this is, barely more than one high school class. But then you go up to Ohio State at 170 or even Purdue at 200. They're still about 10% of the overall grads, but they are a huge class compared to 39 that Colorado graduates. Okay, and then the positive outcome rates, I just want to comment on those again. The ones that we're seeing here, like Purdue 99%, that's pretty much standard for all the majors at Purdue. And the rest of these are all pretty standard except for Georgia Tech. Georgia Tech as a whole has about a 70% placement rate for their engineering grads, which is really, really not good. But 89% of their chemical engineering grads are getting jobs or going to school, which is much higher than their average. So I think while I have a hard time recommending Georgia Tech for a lot of disciplines, it looks like the chemical engineering option is a pretty good one. Okay, and then if we look at the percent grads employed versus the percent grads continuing their education, The employment numbers are actually higher than we see on a lot of disciplines, and the continuing education are a lot lower. So in my mind, that's a pretty good thing, because if we're going to school to get a job and we are able to do that and we go do that, that's great. Chemical engineering as an industry does not look like they immediately send a lot of people to grad school. There are a lot of people who are just getting jobs. But the percent graduates continuing their education is not so small that you'll be left out or the only person doing that if you're going that route. Okay, and then I'll go to median starting salary. They're all in the high 70s or 80s, which is pretty typical. I do see Colorado State as a little bit lower than we have seen, and actually $10,000 lower is pretty significant. So if you are going to go to Colorado State for engineering, it may be a really good option for you if the price is right and you're going to be able to get that education a lot cheaper than going somewhere else. But it is something to be aware of, that you may have less likelihood to get that job you're looking for, and also a lower starting salary. So if you have the same price across schools, you might want to look at this data pretty closely before selecting one. So if you have any more comments or questions about the outcomes or different schools, please leave a comment, and we'll get back to you. Again, this is a representative of the schools that give us good data and that had this major. Not necessarily all the schools. So we'll definitely dig for you if we can, and get more information for different schools if you are looking at things. Just let us know. All right, so the next two slides are first employers and first job titles. What I like to do is just pull from the schools that give us the data. Again, where are their grads going? If you look at specific schools, they are very different, and that goes back to what I was saying about the different areas of the country with different industries. But the first employers here are really representative of how diverse of industries chemical engineering supports. So the first one, Procter & Gamble. Those are consumer products, shampoos and those kind of things. I know that a lot of chemical engineering grads from Purdue go into this industry, because there are a lot of those kind of companies in Indiana. But ExxonMobil and Marathon, both oil and gas. Eli Lilly is pharmaceutical. Sherwin-Williams is more of like a paint and chemicals as we think of chemicals company. If we keep going down, Eastman Chemical, again, has it in the name. And then Dow and Cargill are more agricultural. So just in this list right here, from the few schools that provide us with the companies that hire from them, you can see there's a huge variety. If you are interested in one of these companies, or you never heard of them, it's a good thing to just go look them up. And you can see what they do. And then also I will provide a link to our video about using LinkedIn to find out where these companies are getting their grads or getting their employees. And those can guide you into where you might want to go to school. If you really, really want to work for Eli Lilly, for example, you can go in and find out from LinkedIn where their engineers went to school, and you can target those schools based on where you want to end up later in life. So definitely good resources here. And then the first job titles. So all of these job titles are very much aligned with chemical engineering. We talked about process, so process engineer, manufacturing engineer. Refining would be oil and gas. Chemical engineer is the name of the major, so that's good. What I want to point out is what's not here. So we don't have any finance analysts or those types of thing, consultant, that sometimes when people go into an engineering or get a degree, and then they either can't find a job in that discipline, or they discover that maybe that job isn't for them, we'll start seeing job titles on here that are more consultancy or financy. And that's not necessarily a bad thing, but it may be an indication that there are more grads in the industry than the industry can support. That is absolutely not the case here with chemical engineering. These jobs are all aligned with what we're saying that a chemical engineer would do. Okay, resources. So this is for you to go find out more information about chemical engineering. You can always do a general Google search, but the resources that I will provide a link to in the comments are a chemical engineering overview by the Open Avenues Foundation. And then we talked a lot about this industry organization, the American Institute for Chemical Engineers. They have an Institute for Learning and Innovation, and that's a great resource for finding out more information. All right, so we've gotten to the end. Please like and subscribe. If you have not already, please share with friends. Let them know where you're getting some great information. And let us know if there are more disciplines that you would like to see videos on, or specific information about chemical that we did not cover here. And we will see you on the next one.